Today we're doing the law of cosines. And the law of sines worked under certain circumstances. The law of cosines will work if we have side angle side. In other words, if we have two sides and the angle in between them. And if we have all three sides but no angles. Obviously, neither one of those will work properly with the law of sines, because in order to use the law of sines, you have to have an angle and a side opposite. This one, the first one, you have two sides with the angle between them. You only have one angle, and you do not have a side opposite that angle. It doesn't work. And if you have all three sides, you don't have any angles, so it doesn't work at all. So you have to use the law of cosines. The law of cosines is much, much more complicated than the law of sines. The side length c squared is equal to the square of side length A plus the square of side length B minus 2 times A times B times the cosine of angle C. Much more complicated. As you might guess, this is derivative of the Pythagorean theorem. Okay, that's where the part of this comes from. It is a much more complicated one. And you can use it for any side and angle combination. The thing you need to remember is that this side is opposite this angle that you're using the cosine for. Okay, the side that you're looking for is opposite the side you have, or the angle that you have. That's the key to this one, because it doesn't matter which ones you have. It's the side opposite the angle squared is equal to the square of the other two sides minus 2 times the other two sides times the cosine of the angle. It's the angle and the side opposite are what you're working with the law of cosines. Now, if you solve this for angle C, you can use it to find the angle measurement. The angle C is equal to C squared minus A squared minus B squared all over minus 2AB, or sorry, I messed up. It's still partially right. It's equal to the inverse cosine of, sorry, my bad, C squared minus A squared minus B squared all over negative 2AB. So if you have the three sides, you can find an angle measurement. Okay? So that's how the law of cosines works. Law of cosines has no ambiguous cases. There is nothing ever ambiguous about the law of cosines. Okay? And the law of cosines will work every time. It will give you something. If you have an answer, if you have a solution, it will give it to you. There are no ambiguous cases. There are no possibilities of it being something else. If you're using, if you're trying to solve it and you're using an angle, it will give you somewhere between 0 and 180. So if you've got an angle more than 90 degrees, the law of cosines will give you that angle that's more than 90 degrees. Where the law of sines will only give you one that's less than 90 degrees every single time. You have to figure out if it actually should be more than 90 degrees. Okay, so it's not ambiguous at all. And like I said, if you have all three sides, you have to use this one. Okay. Law of sines is easier to use than the law of cosines, but law of sines will not work in every case. So let's do a couple of examples here. So once again, the first thing you do when you're working a problem like this is draw a diagram and label it A, B, C. And let's see, that's 20. This is 12. And that's 40 degrees there. So first thing you always want to do when you have these problems is draw a freaking triangle and label it. It is so helpful to visualize. It absolutely kills me when students do not even do that to begin with. Okay? Now, what I need to look for is I'm going to have to find the other three parts, just like before. Law of cosines, law of sines will not work in this case. There is nothing that will work with the law of sines at all in this case. So I have to use the law of cosines. I have no choice in the matter, because I have to look for the side opposite the angle I have. I cannot find either of the other two angles, because I don't have enough information to find that. So I set it up. So it's the side opposite, b squared, is equal to the square of the other two sides, and it doesn't really matter which one you put first. 20 squared plus 12 squared minus 2 times 20 times 12 is just the other two sides times the cosine of the angle opposite the side I'm looking for. Yeah, when I did these on my calculator, I'll tell you exactly how I did them. I plugged this all in, figured out what that was, and then I took the square root of that number. I know a lot of teachers and a lot of kids, I want to get b by itself first, so the square root both sides, and then we'll have the square root of this big whole thing. No. 20 squared plus 12 squared minus 2 times 20 times 12 times the cosine of 40. You can type that straight in. Your calculator will not screw that up at all.
So is the b in this case always b?
Well, no, it can fluctuate because if you look at the original formula, what did I have? I had c squared. It's just the side that's opposite the angle that I have. Okay? And I'm just rotating it around by whatever letter it is. I've actually seen some books where they put it for A, where they put it up there for A, they put one up there for B, they put a formula up for C. I'm like, it's so confusing for that. You just have the side, it's the other two sides and the angle. And then you solve this and you get B is equal to 13.3. Okay. Now, if I wanted to, I could use the law of cosines to find an angle, but why bother doing that? Use the law of sines. Use the law of sines. It's so much easier to use the law of sines when you do this. Now, which one should I solve for? This is actually an important question because remember the law of sines sometimes gives you an acute angle when it should actually be an obtuse angle. I'm not terribly worried about that here, but here's what I always do when I do this. I use the law of sines to find the smaller angle. And I know which one's the smaller angle because I know which side is the smaller side. Smallest angle is opposite the smallest side. My two sides are 20 and 12. This angle is going to be smaller because this side is smaller. Does that make sense? Use the law of sines to find the smaller angle because you know that smaller angle is going to be an acute angle. If you're going to have an obtuse angle, it's going to be, one more than 90. It's going to be opposite the larger side. If you pick the smaller of the two sides, you know you're going to have an acute angle no matter what. You know you're going to get the right angle measurement out of your law of sines. There's nothing going to be dealing with any of that ambiguous crap. So I set it up to solve for A. So that means the sine of A over 12 is equal to the sine of 40 over 13.3. And it should come out smaller than 40 degrees because this side is slightly smaller than that side. It should come out less than 40 degrees. So you work it out, solve for A, and you get 35.4 degrees. And then you do side C, which is easy. You subtract this and subtract that from 180, and you get C equals 104.6 degrees. And this is a confirmation that if I used law of sines for C, I would have gotten an error. I would have gotten one that didn't actually work properly in the triangle. I would have gotten an angle smaller than the 40 degrees, and that's obviously opposite the larger side. It wouldn't have worked. It would have been an error. Look for the smallest angle. Whenever you use a law of sines and you have a choice, always go for the smallest one. Go for the one opposite the smallest side. You go across the largest side, you're going to have a very, very good chance of having a problem. Okay? So be careful of that. That's something you gotta watch out for. Go for the one opposite the smallest if you use a law of sines for something. And often, almost all these problems that are like this, use the law of cosines as your first step. Law of sines comes after that. Because the law of sines is easier to use. It's easier to remember. Just one of those things. Okay. But the law of cosines is highly invaluable. You need it. Okay, let's do the same thing on this one. Three sides and no angles. Law of sines would be absolutely useless on this one. You have to have an angle measurement to be able to use the law of sines. So that means I have to use the law of cosine. And once again, look for the largest angle. Use the law of cosines to find the bigger angle if you're in this situation, because you're not going to have any issues. If you do that, then it doesn't matter which one after that one you use the law of sines for. Once you found the biggest one, you know you're okay on the law of sines on anything else. So I look for the angle that's opposite the biggest side. My largest side is this one here. That means my largest angle is going to be that one there. And this is where I use this formula that I solved for angle C. C is equal to the inverse cosine of 10 squared minus 8 squared minus 5 squared all over -2 times 8 times 5. Once again, I do what's inside. In fact, what I did when I did this, making up my key, I did 10 squared minus 8 squared minus 5 squared, got that on my calculator, divided it by this, and I put all of this in parentheses. If you don't put it all in parentheses, and you go divided by -2 times 8 times 5, it'll divide it by -2 and then multiply that times 8 times 5. It'll screw that all up for you. So you have to be careful when you're doing that in your calculator, and then I took the inverse cosine of that. The ANS key, the answer key, is an invaluable key. I used it when I made up this answer key like nobody's business. Okay, when I worked all these problems, the ANS key is awesome. And you should get angle C is 97.9 degrees. Bigger than 90, it's the biggest angle in the triangle. You can't have more than one bigger than 90 degrees. Okay, it's guaranteed to be the biggest one. And then you can do whatever you want for the law of sines for either one of the other two angles. It is irrelevant. They're both going to be less than 90 degrees. You're not going to have to worry about any ambiguity or getting anything wrong on that one. So I did mine for angle B, which was the smallest. Once again, I picked the smallest, but it really doesn't matter on this one, but I like to do the smallest one. Sine of B over 5 is equal to the sine of 97.9 over 10. And you work that out. B is equal to 29.7. And then subtract both of those from 180 to get angle A, 52.4. Okay. We now have what we need to solve for anything in any triangle, right or non-right triangle. If we have one side and a couple of other things, we can solve anything. We can figure out any triangle if it exists. We can figure it out. Law of cosines works where the law of sines doesn't. Stuff that we could not use the law of sines for, we can now use the law of cosines instead. If it's right triangle, that's a whole other ball of wax, but we have all the tools to do that. Give us a triangle in two parts, or I should say one side and two other parts. We got it all figured out. We have the ability to do it. Okay. And part of the reason everybody's all hot and bothered about triangles is because you can break everything down into triangles. If it is a polygon of any shape, it can be redone as triangles, broken down into triangles. Triangles are the most basic polygon. Any polygon can be redrawn as triangles. Just start putting in diagonals until you get a bunch of triangles out of it. This will let us do anything we want for it. Okay? That's why everything's all about triangles. Because any polygon can be redrawn as triangles by putting diagonals in them. Just take a square, you put in a diagonal, you've got 2 triangles. You know, take a pentagon, put in 2 diagonals, you've got 3 triangles. Everything can be broken down, any polygon can be broken down into triangles. And it's extremely useful. And if you're building stuff, triangles don't fall over. Okay, think about a box laying on its side, you stand on it, what happens? It tips over. Triangles don't do that. Triangles are rigid. That's why things are built with triangles. That's why they put cross braces in to make triangles out of it. Okay? They are the basic geometric figure. And if you can do them with that, you can do anything with all the rest of them. And now we can do anything we want. Okay, navigation. A boat leaves Naples, Florida, bound for Key West, 150 nautical miles away. 150 knots, called knots. Maintaining a speed of 15 knots. The crew realizes after 4 hours they're off course by 20 degrees. How far is the boat from Key West when they realize their error? Through what angle should the boat turn to correct its course? And once the turn is made, how long will it take to get to Key West with the same 15 knot speed? Do you know where they came up with knots for speed?
I don't know.
Yeah, they actually had a rope that had dots that were a specific length apart from each other. They would, and they had like a piece of wood or float on the end, and they would drop it off, and they would count how many knots that it took to go in like a minute, and they would convert that over to literally. That's what they did. They had knots. They had a certain distance between each knot on the rope, and they would count. Okay, go to the water. There's 1, there's 2, there's 3, there's 4. The minute's up. How many knots did they do? They could figure out their speed from that. Actually, kind of cool. And a nautical mile is not the same as a mile on land. They're actually a little longer. Okay. Once you figure out A, you can figure out C without doing B. Right? Because if you know how far to go, you can figure out how long it's going to take you at the speed. You don't need B to solve C. So A and B are actually not quite connected, but let's look at the situation. So we have Naples, Florida, going down to Key West. And this is 150 miles. Now, it doesn't say which direction they are off by, whether they're going 20 degrees to the west or 20 degrees to the east. It doesn't really matter. We just know that they're off by 20 degrees. Here they made their error, and then they have to make their turn. Okay. So we need to figure a couple of things out. First of all, we got to figure out our distance from Key West. But how far have they actually already traveled? How far have they gone from here to here?
4 hours.
4 hours at how fast? 15 knots. 4 times 15 is 60. So they've gone 60 knots. 60 nautical miles. That's how far they've gone. Distance equals rate times time.
Wait, what is a unit for the knot? Is it like 1 knot
or not, I believe that's what it is. Nautical miles. Knots for speed and nautical miles are essentially the same thing. Yeah. So we have that. Now we can solve for some of our other parts. So how far away is the boat? So we want to look for that. So you want to find that distance there. That will answer our question A. Right? Not a big deal. We have two sides and the angle between them. Two sides and the angle between them. That's the law of cosines. Two sides and the angle between, that's the law of cosines. So x squared equals 150 squared plus 60 squared minus 150, sorry, minus 2 times 150 times 60 times the cosine of 20 degrees. Yeah, two sides and the angle between them. That's the law of cosines. The third side, the one that's not between the two angles, or not between the two sides, okay, two sides and the angle between them, that would give us the third side of the triangle. That's what the law of cosines will do for us. And we figure out that they are 95.8 nautical miles away. And I do think KN for nautical miles, but I'm not sure of that. I know MI for regular miles. I think KN for nautical miles, but I'm not positive. I'm not absolutely positive off the top of my head on that. I do think that's what it is. I know KN for knots for speed. I think nautical miles is the same way though. Because NM would look like Newton meters, and that's force. Okay. So we know how far off course you were. Now we can figure out real quick if if I were doing a test, I'd take that, divide that by 15, right, to get the speed, to get how long it's going to take. Distance divided by rate equals time. So if you want to answer question C, you just divide that by 15. 95.8 divided by 15, and that will take them 6.4 hours. So if they've been going 15 knots, it would have taken them 10 hours. Now they're going 6 plus 4. It's going to take them an extra 20 minutes or so. That's not that bad. Okay, now here comes the fun part. We got to figure out what the angle they are turning is. Which is not that angle there. Because you want what they turn. They're headed off this way, and they need to turn that way. The angle they turn is not the angle in that triangle. The angle they turn is what they have to go, oh, I got to go this many degrees that way. So that's the way they're navigating, right? So we need to find that angle. Not a big deal, though. We will actually get this angle from the law of sines. And we can use the law of sines now to try to find this angle here, to try to find theta. Okay? But when we do this, you'll kind of see what happens here. It's interesting. So I want to set it up to see if I'm going to find theta. So I have sine of theta over 150. Is equal to the sine of 20 over 95.8. What do you get for that? What did your calculator say that theta is in this case? $32.4. But that's not going to work, is it? No, there's no way that'll work. This side here is considerably longer than that side there. It's not. There is no way that this angle is 32.4, because that means that this angle here, which is opposite the shortest side, because this side here is 95.8, right? So that means it's the shortest side. This has to be the smallest angle. These two here, if this is 34 degrees, there's no way that will actually work. Because these two combined here will be 50. That means that's going to be like around 130-ish or 100, give or take. There's no way that this angle here is more than those two because it's opposite the smallest side. This is opposite the biggest angle. This is one of those ambiguous cases. So what is theta? Theta is actually 180 minus 32. Theta is actually 180 minus 32.4, which is 147.6. So this angle here is actually 147.6. However, it's out our angle we are turning. No, now I do want to find the angle, but what is the angle we're turning? 32.4. It actually will give us the law of sines, doesn't give us the angle for the triangle, but the law of sines does actually give us the angle we want to turn. This angle here that we want to turn is 32.4 degrees. It's not one that will work for the triangle. This is one of those weird things where its law of sines doesn't work out. It does give us the correct angle for what we're looking for here, but it doesn't give us the correct angle for the triangle from the inside. So what do we want to turn? We want to turn 32.4 degrees. Navigation's a goofy thing. And navigation's a goofy thing. Imagine having to do this by hand without a calculator as you're off sailing the 7 seas, so to speak. All you're working with is a compass and a sextant. You know what? It's amazing, amazing sometimes that they actually found their way to the places they were looking for. All right, baseball. America's pastime. The worst ratings there is. Well, the Pro Bowl last year, one of the worst football games there is in the NFL. Absolutely a complete, total joke. I mean, my wife and I, we had it on in the background. She goes, wait, he wasn't tackled. I go, no. He hugged him. In the Pro Bowl, that's the equivalent of a tackle. If you give him a hug, he's been tackled in the Pro Bowl. Pro Bowl still pulls better ratings than a couple of the World Series games last year. So, yeah. Baseball's hurting. Well, that's a beautiful game, though. Okay, so the distance between bases on a Little League baseball field is 60 feet. If it's 280 feet from home plate to the place in dead center, how far is it from the fence to third base? So in other words, you got a guy on second. The guy at home hits a fly ball straight out to dead center. The guy catches it. Or he catches it. The runner tags and goes for third. How far does he have to throw it in order to get the guy out? That's the question we're asking. That's the question we're asking. Got to pull a Bo Jackson. Ken Griffey Jr. Okay, I'm dating myself. Bo Jackson was a remarkable. You should watch football. Everybody loved his football. You should watch some of his baseball highlights. He literally ran up the center field, up the outfield wall, like 3 steps up the wall to catch a fly ball before it went out. And then there's a time he struck out, and he's walking back to the dugout, and he's got his bat on his helmet. He pulls it down and snaps the bat in half over his head. That was impressive. That was impressive. I saw him do that live, and I'm like, holy crap. So, this is what we got. We know that it's 60 feet between bases. We know it's 280 from home plate to the wall. We're looking for this here. What do we need? We need an angle. And the best angle we can try to get, the only one we can really get here is the one that's going to let us use a lot of sines. It's the angle down between the two sines. What is the shape of a baseball diamond? This is a square. What is the angle measurement of one corner of a square? 90. What does the diagonal of a square do to that 90-degree angle? Splits it in half. So what is this angle down here? 45 degrees. Now we got everything we need. X squared is equal to 280 squared plus 60 squared minus 2 times 280 times 60 times the cosine of 45. Then you solve it and you get, he has to throw it 241.3 feet. 241, let me write down the meter here. 241.3 feet. Hope that kid's got an arm. That's why you throw it to the shortstop. You relay it because very, very few kids playing Little League have an arm that can throw it 241 feet.
Very few kids can also be hitting 200 feet.
I played Little League 1 year.
One
I got
year.
home runs. What? I know. I was actually one of the biggest kids out there. I also got the first out of the entire Little League season. I still have the ball, the game ball from getting that first out. Some kid popped up a pop fly. I caught it, and they stopped the game, and they took it, and they, and here's the game ball, first out of the whole season for anybody. And I'm like, oh, that's cool. My mom put the name of the team and the date on it. And everybody, I still have it somewhere. I mean, I was like a little kid. I was like maybe 3rd grade, 4th grade, something like that. All right. I like this one. Requires a little extra work. Assuming that circles are tangent, which means the edges touch each other, because that's what tangent means. They touch in only one spot. They're not secant. Find the lengths of the sides of the angle measurements of triangle ABC. So we have triangle A, B, C. We want to find the sides lengths, and we want to find the angle measurements. Well, side lengths are actually not that hard to do. Side length BC is actually the easiest one. Yeah, it's 15. 8-unit radius, 7-unit radius, 7 plus 8 plus 15. Right, 7 plus 8. That's an easy one.
8 8.
Yeah, AC is 20 all the way out to the edge, and then 7 more back. 20 minus 7, 13. And the same thing for AB. It's 20 units all the way out, and then 8 units back. 20 minus 8 gives us 12. 3 sides, now I can start finding angles. Can't use the law of sines because I need an angle for the law of sines. I have to use the law of cosines. And once again, when you use the law of sines to find an angle, use the law of cosines, use the law of cosines to find the largest angle, which in this case would be which one? A. Opposite the biggest side, find the one that's opposite the biggest side, find angle A. A is equal to the inverse cosine of 15 squared minus 13 squared minus 12 squared all over negative 2 times 13 times 12. And you get angle A is equal to 73.6 degrees. Yeah, you want to find the one opposite the largest one you possibly And then the other two angles, pick one, find it using the law of sines. Once again, I generally like to find the smallest one, but it does not matter. They're both going to be acute because the largest angle is acute, the other two are acute. It is irrelevant which one you find, whether it's B or C. I actually, in my notes, I found B next. Okay. So the sine of B over 13 is equal to the sine of 73.6 over 15. And you get B is equal to 56.2. And then you solve C by subtracting those two from 180. C would be equal to 50.2. And if you solve for C, because it's the smallest, you'd still get the same number, and you'd still get the same number for B. Either way, it doesn't matter. So now you have right triangle stuff, Pythagorean theorem, right triangle trig, if it's a right triangle, if it's not a right triangle, law of sines, law of cosines, we'll get you everything else. Okay? You are going to have a quiz mignon. Well, actually, no. You guys will be Wednesday, not tomorrow. Next time we meet. Your chapter test is a week from Wednesday. Okay, short chapter, only 4 parts.